Can you simplify 2 to the power of 3 times 2 to the power of 4 without calculating it separately? Well, there's actually a shortcut for this, and it's one of the most important rules in indices. So by the end of the video, you'll be able to understand how to work out questions like this without stress. Now, the first rule is the power multiplying power that says a to the power of m times a to the power of n is equal to a m plus n, which is saying 2 to the power of 3 times 2 to the power of 4 is equal to 2 to the power of 3 plus 4, which is equal to 2 to the power of 7. When your base is the same, you can simply add the exponents or the power. The same base, you can simply add the exponent or the power. To understand this visually, 2 to the power of 3 is the same thing as 2 times 2 times 2, right? And 2 to the power of 4 is the same as 2 times 2 times 2 times 2. Now, if we count, we have 1, 2, 3, 4, 5, 6, 7. 2 to the power of 7. So without going through all the stress of expanding, then counting how many 2's are there, the rule is there. The only exception is you need to have the same base. Now, what if we are doing 2 to the power of, or x to the power of 2 times x to the power of 4? Because of our rule, we know this will become x to the power of 2 plus 4, which will give us x to the power of 6. But if you want to show it visually, this is also the same as x to the power of 2 is x times x. And x to the power of 4 is x times x times x times x. If you count it here, 1, 2, 3, 4, 5, 6. This becomes x to the power of 6. Alright, so the second rule is the dividing power, whose formula is a raised to the power m all over a to the power of n is equal to a m minus n. That means if you have something like, let's say, 5 to the power of 2 divided by, or let's say 5 to the power of 3 divided by 5 to the power of 2, this will simply be 5 to the power of 3 minus 2, which will give you 5 to the power of 1. The rule is still the same. Now, the way of also visualizing is still the same, just like what we did with multiplication. So if you want to visualize this, it's simply 5 to the power of 3 is 5 times 5 times 5, right? And 5 to the power of 2 is 5 times 5. I know here that 5 can cancel 5 out, 5 can cancel 5 out, and left with this. So this becomes 5. 5 to the power of 1 and 5, they are the same thing. Also, if you have something like, let's say, x to the power of 5 all over x to the power of 2. You know, with this formula, it is simply x to the power of 5 minus 2, which is equal to x to the power of 3. You can visualize it too, like what we have been doing recently. X to the power of 5 is simply x in 5 places, abi? So this becomes x times x times x times x times x all over x to the power of 2. This is x times x. X will cancel x here, x will cancel x here. I'm left with this. So this becomes x to the power of 3. So whichever way you want to use to get your answer is still the same. But please take note. Make sure the base is the same. So if you have 5 here, you have 5 here, it works. But if you have something like 3 to the power of 2 over 5 to the power of 4, this doesn't work. Oh. This is different. So for your formula to work, you need the base to be the same. The base must be the same. The base of this one must be the same with the base of this. The third rule is power of a power. That is to say that am to the power of n is equal to am times n. Assuming you have, let's say, 3 to the power of 2 raised to the power 3. This is simply telling you that it is 3 to the power of 2 times 3, which will give you 3 to the power of 6. To see how this works, what you simply need to do is 3 squared raised to the power 3 is simply saying 3 squared times 3 squared times 3 squared, right? And 3 squared is what? 3 times 3 times 3 squared here is 3 times 3. 3 squared here is 3 times 3. Over here you have 1, 2, 3, 4, 5, 6, which is also equal to 3 to the power of 6. So this formula just makes it easier for you. What if you have x to the power of 2 or to the power of 6? The formula is telling you that what you need to do is just x to the power of 2 times 6, which will give you x to the power of 12. And you can also write expanded like this too. There's no issue. The fourth law, which is power of a product, is telling you that AB all to the power of n is equal to AN BN. So that when you have bases and that base is multiplied by one power, maybe 2 base or 3 base, and they are all multiplied by one power, this power can be distributed to this first base and the second base. If you have something like 3x all to the power of 2, this becomes 3 square x square, which will give you 3 square is 3 times 3. So that would be 9, right? So this would be 9x squared as your final answer. So power of a product is just telling you that anytime you have a base or you have more than one base, maybe 2 bases, they are all have the same power here. This power here is entitled to this and this. What if you have something like 5xy all squared? This becomes 5 squared times x squared times y squared. 5 squared is equal to 5 times 5, which is 25. So this is 25. X squared, we can just leave it that, x squared and y squared. This is your final answer. So anytime you have bases like this that are all inside the bracket and with the same power, you just distribute the square to each one of them. So this next rule is almost like the rule number 4. For this one, power of a quotient is simply saying when you have this and this all to the power of n there, a to the power of n, n to the power of n. So you are distributing that power to each one of them individually. What if you have something like x over 3 all to the power of n? This becomes x to the power of n all over 3 to the power of n. What if you had something like 2 over 5 all squared? This becomes 2 squared over 5 squared. And you know that 2 squared is 4 because 2 times 2 is 4. So this is 4. 5 squared is 25 because 5 times 5 is 25. So this becomes 4 over 25. That is all under power of a quotient. Alright, so I've given you the 5 laws of indices. Now there are more laws, but let's us work on these questions. Feel free to pause your video and make sure to work them out. So we have x to the power of 3 times x to the power of 5. Our first rule of indices, multiplication power. So this is going to be x to the power of 3 plus 5. Remember, because we have the same base, that's why we can use this rule. This becomes x to the power of 8 as our final answer. For this, you have y to the power of 7 over y to the power of 2 or y squared. The second law, division. So this becomes y to the power of 7 minus 2, which becomes y to the power of 5. For this one, this is power of a power. So for here, we have a square all to the power of 4. According to the rule, you can simply make it a 2 times 4, which is equal to a to the power of 8. And that is the final answer. But we are not done yet. What happens when our index is 0? What about a negative index? And what on earth is a fractional index? That's what we're going to be tackling in the next video. So make sure to subscribe. I'll see you there. Bye-bye.